Yes, so as we were saying now, differentiation now is that branch of mathematics which deal with gradient finding. Okay, it has its roots in the difference in the y variable divided by the difference in the x variable. So I guess that's where it got its name from, differentiation, because you're basically finding the difference in y with respect to the difference in f at x, and that's gradient, that's rate of change. Okay, and here you have some symbolism given to it: the delta, capital delta, small delta, all right, and English d, and the English d, dy dx, and depending on the function that you may be given, all right, the differentiation now might appear a little bit difficult, and you may even forget that it's differentiate, that you are differentiating. Okay. All right, you may have to differentiate a sum function, and I'm purposefully not really going back to our notes because I just want to promote that you can just do some new notes, new research, and it will give you some new insight. You may be required to differentiate a sum function. So let's see what Google has to say about that. How to differentiate a sum function. The sum rule says the derivative of a sum function is the sum of the derivatives. Okay, so the differentials of the sum is the sum of the differential. And look, you have the sum rule here. An image pops up there. It's not so clear, but there are more images for the sum rule, differentiating the sum function. Okay, it's been a little bit clear. Okay. So you do that, you don't have to depend solely on the notes that you are given in any session that you are going to, that you are following, any class that you are following. You don't have to restrict yourself to the notes of that particular class. You can broaden your horizon. Okay, take some key notes or some key terms and then look it up in your spare time, just like what we are doing now. The sum function, where is the symbolism that was in the image? Where is it? Where is it? Okay, here it is. Okay, so therefore now the sum of the differentials is the differentials of the sum. So if you want to differentiate a sum function is such that, you see, when you're looking at a function, anywhere x is can be considered a mini function in that function. Okay, anywhere x is, it can be anywhere x is can be considered a mini function in that function. Okay, so just bear that in mind. So take, for example, yeah, that's the introduction for today. Take, for example, you've got a function called y. Y is equal to 5x raised to the power of 4, okay, plus 9 sine of x. Okay, and bear in mind, we said anytime you see x and y are potential variables in the real world, all right? So x could mean anything. X could mean time, and y, x could mean time, okay? Time raised to the power of 4, we said, and y could mean distance, okay? So just bear that in mind, all right? X and y are basically representing any potential variable that you are dealing with in your particular case, but you will see a lot of x and y's because you know, to make it general, to focus on the actual process itself. Okay, and specifically we're talking about differentiation, okay, of some function. So if all where x appears can be considered a mini function in the entire function. So the entire function is y. The entire function is y. But in that function now, x appears here in the 5x to the 4, and x appears here in the 9 sine x. And you have a plus separating it. So this can be called a sum function. Okay, this can be called a sum function. So if you have to differentiate a sum function, you can differentiate each term separately. Bear that in mind, a term is separated by a plus or minus. Okay, so bear that in mind. But you may not have a sum function. You may have what you call a product function. Okay, you may have a product function. All right. Product means multiply. Okay, product means that you multiply. Now the rules are different now for a product function. You have what you call the product rule. Okay, here you have an example of the product rule. We talked about the product rule already. Okay. So let's take a look at what this will give us with regards to the product rule. The product rule, all where x is appearing is a product that's happening between them. Okay. So here we have an example of a sum function. If, for example, instead of a plus, you don't have anything. If there isn't anything, then it's a multiplication. Bear in mind, you have different symbols to represent multiplication. You have the famous X. You have the dot in the middle. Okay, not a decimal, the dot in the middle. I'm looking for the dot, use that as a dot, and you also have the star, okay, or you don't have anything at all. So this now you cannot apply the sum function here, the sum rule. You have to apply what you call the product rule, okay, and here you have different, you have some video on product rule and quotient rule. Okay, as we are there, we can just talk about the quotient rule. So the quotient rule means that we divide. So you may have a function that looks like this. A numerator and a denominator. Okay, so just put in the fraction sign there and put this in the denominator. Then you have what you call a quotient function, and you have to apply the quotient rule. Okay. And that's what we discussed. We discussed that last session. So depending on the function, the level of difficulty may increase, and you may even forget that you are differentiating, but never forget that that is gradient that you are finding. But whenever you are differentiating, always remember that you are finding gradient, you are finding a rate of change. Very important branch in mathematics.